Good afternoon. Stephen Elliott of Coherent Breathing, joining you again. Today, I pick up where I left off last video, this being a discussion of heart rate variability or respiratory sinus arrhythmia, and how those phenomena vary as a consequence of breathing, particularly how they vary as a consequence of deep rhythmic, resonant breathing. The reason they do, of course, is because as we breathe, it's generating a large wave of blood in the circulatory system. This wave returning blood volume-wise to the right heart and filling the lungs during inhalation, and then the blood being ejected from the lungs via the left heart out into the arterial tree during exhalation. And there are specialized receptors in the arterial tree, in particular in the brain, that pay attention to the arterial pressure and consequently the blood flow. And based on what is going on with pressure and blood flow, the baroreceptors will signal the brain to modulate the vagus nerve, thereby modulating the sinoatrial node in the heart and consequently the heart rate. Not just the heart rate, but also the volume of blood that is ejected from the left heart during each pulse. This applies to the right heart as well, where inhalation is effectively a right heart-centric emphasis, and exhalation is a left heart-centric emphasis, where I argue that, as a rule, the volume of blood that is drawn back from the extremities during inhalation should equal the volume of blood ejected from the lungs through the left heart into the arterial tree during exhalation. That way we have equal blood volume moving in both arterial and venous trees on a continuous basis, and we can ward off any specter of essential hypertension. Now, what you see here in the graphic is me wearing a hemo-encephalograph here at my forehead. This is an infrared device that has the capability of looking through the bone of the skull into the blood volume in the brain. And what I'm trying to assess here is the correlation between the blood volume observed at my earlobe using Valsalva Wave Pro and the blood volume observed in my brain using the HEG instrument. And you can see that when I switch views here, thank you, you can see that there's a high degree of correlation between the two. The wave in the HEG has not been flipped. The signal has not been flipped, as I have done for the wave being observed by Valsalva Wave Pro at the earlobe. So we see them being roughly 180 degrees out of phase here. Had I flipped the signal in the HEG, then we would see the peaks and valleys correlating very highly between the two signals. This is evidence enough for me to know that the wave does exist in the brain and is modulated in very much the same way as we see it at the earlobe or anywhere else that we choose to observe it on the body, but in particular at the earlobe because it is, of course, on the head and the brain is just inside the skull. So here we have the makings of a theory that I have put forward regarding the circulatory system, this being that it is called the circulatory system because blood is intended, designed, if you will, to flow evenly in a circle. where we have a rise in venous blood during inhalation and a rise in arterial blood during exhalation, the two meeting at the capillary membrane, of course, facilitating the fluid flow and blood flow exchange throughout the body, including the trillions of cells that rely on blood flow and fluid flow throughout the body to remain vital, nourished, cleansed, etc. This is how the cells of the body are kept by the central nervous system and autonomic nervous system in good health and standing, including our mitochondria, of course, which are the components of our cells that produce energy. And they rely on the oxygen that the blood is carrying across the capillary membrane and into the extracellular fluid, ultimately into the intracellular fluid for oxygen, and that the cells then use to generate electricity via the Krebs cycle and the process of splitting water into hydrogen, oxygen, and generating electricity flow in each of the cells. This making up the total electricity generated by the human body. Thank you for your time. I hope you enjoyed, and we'll see you next time.